I've turned into a English writer with all this words that I've had to put on the board. Let's extract the mass from it. We're continuing on our trend with the normal distribution. This is an interesting one for sure. We've got a botanist studies the weights of mangoes grown at a particular orchard. After measuring a large number of them, she finds 5% weigh more than 540 and 1% weigh less than 460. Assuming the weights are normally distributed, find the mean and standard deviation. Okay, now what did I tell you guys? You always need to do with the normal distribution, a sketch. So here, let's define our distribution. So let's let x equal weights of mangoes. So always define what we're talking about. X is normally distributed mu sigma squared. We don't have those values. Now 5% weigh more than 540 grams. So if I was to draw a normal distribution here, we could just do 1. We have mu and sigma. 5% being more than 540. So 540 is over here. More than that is 0.05. And then 1% is less than 460. Now, what did I tell you guys you need to write down? It's always about the cumulative statement, which in the Z distribution I told you guys was phi. Okay? So here we need to write a cumulative statement for both of these. So the probability that x is less than 460 is 0.01. That's good. That is a cumulative statement. However, for this, we need a cumulative statement up to 540. So the probability that x is less than 540 is 0.95. Yeah, all probabilities add up to 1. So up to this point will be 0.95. Now we convert this to phi, okay? Because we need to expose mu and sigma, which comes from doing the transformations to the Z distribution. Now you need to be familiar with phi. Phi, we take our x value, we subtract the mean, divide by the standard deviation, is 0.01. Here, phi of 540 minus mu over sigma is 0.95. Then we do inverse phi. Inverse phi indicates to us that we need to use our inverse normal tables, which, just reminding myself, we don't need normal tables anymore. We can just do it in the calculator. So go menu 7, 3 inverse normal, the area is 0.01, minus 2.32. Now that value, we're going to store it. So I'm going to store as A. So when I do inverse phi of this, I get 460 minus mu, then that sigma I'm going to times up as well. So I get minus 2.32 dot 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 sigma. And this value, I've stored it in the calculator as A. So I move that over, I get 460 is mu minus 2.32 dot 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 sigma. So it's giving us simultaneous equations vibes. Doing the exact same thing over there, so I'm going to change it to 0.95 now. 1.64, I'm going to store that as B. So I get 540 minus mu. Then remember, we're going to times through by sigma as well. 1.6448, whatever. Sigma, move that over. We get 540 is mu plus, have I stored that? I have. 1.64 dot 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 sigma. Now we have to solve this. Now, in the exam, I would just show the bare minimum because really and truly, you're just gonna use the calculator for this, okay? So I'll just show the bare minimum in terms of finding sigma. We're gonna take the equations away, okay? So I'm gonna say 540 minus 460, mu minus mu would cancel. We would get 1.64 plus this, because it's a double minus, right? So we get 1.64 minus this sigma, which you're going to divide by that. So you get 1.64 dot 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 minus 2.32 dot 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 is sigma, which I'm going to round as well. I haven't put in my question how much I want you guys to round it to, but I'll figure it out once I get the answer. So from now, I'm not going to type that in. I ain't got time for that. I'm going to go menu A, polynomial, not polynomial solver, menu A, simultaneous equation, 2 unknowns. So I'm going to put 1, A, so alpha A, which has been stored for me, 460 Then here we have 1 for the coefficient of mu. Then 1.64, I stored that as B. And then we have 540. So we have that, but we also have mu is about, I'm just going to say 507, 3SF. And then sigma 20.1. So let's just do 3SF for both. Okay, it's my question. I can round it how I want in it. So part B. That'll be worth a lot of marks, 5 marks in the exam, something like that. I've seen them give 6, but I think 5 is more realistic. All right, so with that information, it's saying further analysis indicates that mangoes under 450 grams are tiny and require a special packing process. A wholesaler buys K mangoes at random from the orchard. If there has to be less than 15% chance that the wholesaler's collection contains any tiny mangoes, find the largest integer K. All right, so what is this giving us vibes of? We have K mangoes. Yeah, so, I don't know. Let's just draw some mangoes. 1, 2, 3, 4, 5. Yeah, we have K mangoes. How many of these do we need to have such that I want there to be less than 15% chance that any of these are tiny? I basically don't want them to be tiny. I want there to be a less than 15% chance that any of these are tiny. Okay, so you'd go one by one. This is giving me binomial distribution vibes. Okay, so here we're going to have to define our binomial distribution and figure out how it connects to the normal distribution. Okay, so let's use y. Y equal the number of mangoes that are tiny out of k. Okay, so when we do this, we think to ourselves, okay, so we need n, well, n is k, and we need the probability of any individual mango being tiny, all right? So we need to figure out the probability of finding a tiny mango. Well, that would just be 450 and below. So if we look at our original, we just need to work out 450 and below. What's the probability of getting a mango less than 450? So for that, we're going to go probability of x being less than 450. Okay, so my calculator's here. So that we're going to set the upper to be 450, and then the lower, we're going to do minus 99999. 450. Let's do 20.1 and 507. So it's a small number. I'm going to store that value. Store it as C. So it gives me 2.28 ... times 10 to the minus 3. I'm just going to make a note. I've stored that as C. So y is binomially distributed k and 2.28 ... times 10 to the minus 3. Okay. I want 0 tiny mangoes. Okay. So the statement is, if there is to be less than 15% chance that the wholesaler's collection contains any tiny mango. Okay. So there needs to be less than 15% chance that the wholesaler's collection contains any tiny mangoes. Okay, so we want the probability of y. So how many tiny mangoes do we want? We want that to be 0. Okay, so we want the probability, well, we want y is 0, but we're basically saying the probability of having one tiny mango or more needs to be less than 15%. So the language here, we need to be very careful. Okay, so we have this box of mangoes. The probability of having at least one mango, so one mango or more, I want that to be less than 15%. Yeah, I don't want one or more mangoes to have or to be tiny. So I want the probability of having at least one mango being tiny. So at least one mango being tiny, I want that to be less than 0.15. Okay, but we have to reverse this, meaning I'm not going to calculate the probability of 1, probability of 2, probability of 3, probability of 4, all the way up to k, because I don't even know what k is. add them up and set it to be less than this. Instead, we think of it as the only thing we don't want is 0. To calculate the probability that y is greater than equal to 1, we do 1 minus less than equal to 0, but you can't have less than 0, so we just say equals 0. And this is what I was talking about before, the probability of 0. So you could say 0 to be, you want the probability of having 0 mangoes to be 85%, okay, or more. So when we rearrange this, we're going to get this is greater than 0.85, okay? So when we rearrange, we get the probability that y equals 0 to be greater than 0.85. And we need to solve this, okay? Now, how do we do this? My year 12s, well, they're year 13s now, will be very familiar with this. This, how do we describe it? You should be shouting at the screen right now. We say this is the probability of all failures, okay? All failures. The probability of finding a tiny mango is this. The probability of not finding a tiny mango is 1 minus this. So we want all of the mangoes to not be tiny, which would be this probability, 1 minus this. But we also have to the power of k. Yeah, because there's k mangoes. All right, the numbers here are not that nice, right? We want that to be bigger than 0.85. Right, how do we solve that? Well, the unknown is in the power, so we need to use logs. So let's use logs. I mean, if you want, our favorite function, we can use ln, if you want. If you do ln on both sides, you would get k, you'd bring down the power, k ln of 1 minus 2.28 times 10 to the minus 3, greater than ln of 0.85. And then we divide. Now you need to know here that this number here is between 0 and 1. This is negative, so the sign is going to flip here. Yep, so the sign is going to flip. K has to be less than ln 0.85 over ln of 1 minus 2.28 times 10 to the minus 3. K has to be less than. Now I did store that value as C. So I'm going to go menu 1 fraction ln of 0.85 over ln of 1 minus C. 71.03. So K is 71. What is the integer below that? Okay. And that's it. That is a tough question. So what have we just found? We found if we had a box of 71 mangoes, you have less than a 15% chance, you have less than a 15% chance that this collection has any tiny mangoes, okay? And that is it. So 71 is your solution. All right, guys, if you learned something today, I'd really appreciate if you hit the thumbs up, like the video. I've just said that. Make sure you're subscribed for more maths content. My brain's hurting right now. I'm not feeling very well. But yeah, stay tuned for more maths videos. If you're interested in my A-level maths courses, more details in the description. Head to the Lungang Reddit page if you want to submit your own questions and get feedback from the community. I'll see you in the next video. Nice one, White.